the 9 most terrifying theories of the universe. Ever since man has existed on Earth, he has wondered how the planet on which he is born, lives and dies, and the rest of the universe that surrounds him was formed. This has given rise to various theories, from those that seemed most logical and obvious in principle, such as that the Earth was flat to Einstein's general relativity that hit physics like a locomotive at 300 km per hour, giving rise to the most remote hypotheses of human intuition that seem far-fetched. How did the universe? Why is it, as dozens of theories have tried to explain it throughout history, and some are not pleasant or are simply terrifying? We are going to dedicate this video to some of the most fascinating scientific theories about the universe, about matter, space, and time, and the model invented by Einstein that combines spatial and temporal dimensions and is so difficult to assimilate. Don't forget to subscribe to our channel and turn on notifications to keep up to date with our updates. Number 1. Multiverse Theory. This hypothesis postulates that there exists a great universe called multiverse that is a set formed by different smaller universes. It is supposed that together all these universes, or the multiverse, include the totality of what exists: matter, space, time, energy, the laws and physical constants that explain it. The different universes that form the multiverse have received the names of parallel universes, alternative universes, multiple universes, and other denominations, all united by the same laws of physics. The theory is not new and has been debated for more than 2,500 years, since it was first discussed by the philosophers of classical Greek antiquity. The idea of several infinite worlds was first suggested by the pre-Socratic Greek philosopher Anaximander in the 6th century BC. Although there is debate as to whether he believed in multiple worlds and whether they were occurring or coexisting, however, it is to the atomists of ancient Greece that the first notion of innumerable worlds can be attributed, beginning with Leucippus and Democritus in the 5th century BC and continuing with Epicurus, Chrysippus, and Lucretius. Over time, and with the development of the sciences, the concept has evolved and has been debated in various fields, including cosmology, philosophy, physics, astronomy, and mathematics. Part of the physics community holds that rather than a scientific theory, the multiverse is a philosophical notion that cannot be empirically disproved. In recent years, some scientists have analyzed and interpreted information in an attempt to present evidence for other universes. And both supporters and skeptics of the theory have emerged within the scientific community. Critics point out that the multiverse concept lacks both testability and falsifiability, that they are indispensable in scientific research, raising metaphysical and resolvable issues. The Swedish-American physicist and cosmologist Max Tegmark and the American theoretical physicist and mathematician Brian Greene proposed a 4-level scheme for classifying universes and the multiverse. Level 1 considers alternative universes to be extensions of the universe as we know it, and Level 2 postulates that universes coexist with different physical constants. Level 3 is a many worlds concept based on interpretations of quantum mechanics, and Level 4 is a definite set or mathematical universe based on the theory of everything or master theory of physics. This theory of everything is a coherent and all-encompassing hypothetical singular conceptual framework of physics to fully link and explain all aspects of the universe. Number 2. Simulation Theory. This theory postulates that everything that exists is a simulated reality as a kind of computer simulation. This could include conscious minds that know or are unaware that they are living within a simulation. Although in this technologically advanced concept, computer-generated environments, scenes, and objects that create in the user the illusion of being immersed in another world are easily distinguishable from the real experience. On the contrary, in simulated reality, it would be very difficult or impossible to separate it from the real reality. The main proponent of simulation theory is the Swedish philosopher Nick Bostrom, founder of the Future of Humanity Institute at the University of Oxford, and author of several books on the subject. The author of several books on anthropology, existential risk, ethics of superhuman creation, and risks of superintelligence in 2003. Bostrom wrote an article in which he planted the idea that we might be virtual beings living in a computerized simulacrum, and since then physical philosophers and other scholars have debated the issue. Bostrom envisioned a technologically adept civilization possessing enormous computing power and needing only a fraction of that power to simulate new realities with conscious beings. The notion of simulated realities had already been popularized in 1999 in the movie The Matrix. And the idea has roots in both Western and Eastern philosophical traditions, from Plato's allegory of the cave to the butterfly dream of Chuang Tzu. Even the restless Elon Musk recently stoked the idea that reality is a simulation, providing his own probabilistic calculation in a 2016 lecture by pointing out that the odds that we are in the basic reality are 1 in billions. The California Institute of Technology Computational Mathematics specialist Holman mused on the matter by pointing out that if the simulation has infinite computational power, there is no way for you to see that you are living in a virtual reality, because it could compute whatever you want with whatever degree of realism you want. Other scientists have been more drastic in judging simulation theory, as the German theoretical physics writer and YouTuber Sabine Josen-Felder called it pseudoscience, and South African cosmologist George Ellis said it is totally impractical from a technical point of view. Number 3. Theory of white holes in the framework of general relativity. A white hole is a hypothetical region of space-time which, contrary to a black hole, does not allow matter, light, energy, and information to enter and cannot be accessed from the outside. While nothing can escape from the black hole, nothing can enter its opposite cosmic brother. Stephen Hawking and other scientists have proposed that supermassive black holes generate a supermassive white hole, and for several decades it was thought that white holes were an improper invention. White holes were an improbable invention of general relativity resulting from the same equations as black holes, their collapsed stellar twins. However, more recently, some theoretical physicists have been wondering if these supposed space-time entities might not be the flip side of the same thing. Experts describe a white hole as the time reversal of a black hole, as the video of one of these played backwards, or in the same way that a bouncing ball is the time reversal of an identical falling one. While the event horizon of a black hole is a place of no return, that of a white hole is the limit of non-admission, a club so exclusive of space-time that nothing and no one can enter. In theory, objects can exit a white hole and interact with outer space, but since nothing can enter the interior of the supposed cosmic entity, is isolated from the past and present of the universe, and no outside event affects it in any way, it is more disturbing to have a singularity in the past that can affect it. A singularity in the past that can affect everything in the outside world, points out James Barden, professor emeritus at the University of Washington and one of the early black hole specialists. Einstein's general theory of relativity hit physics like a tsunami in 1915, and more than 100 years later, theoretical physicists. It took 40 years to understand black holes, and only recently have people focused on white holes, says Carlos Robelli, a theoretical physicist at the Center for Theoretical Physics in France. Perhaps it will take less time to understand white holes. Number 4. Superfluid space-time theory. The superfluid vacuum theory is a hypothesis of physics and quantum mechanics in which the physical vacuum behaves like a superfluid or condensate. In the 1920s, Albert Einstein and the Indian mathematical physicist Satyendra Nath Bose published a paper on the properties of light photons. B described some rules. Einstein applied them to the atoms of a gas, asking himself how they would behave under these rules. This led to the discovery that at very low temperatures most atoms are in the same quantum state, the least energized state possible, the grouping of particles in this state of minimum energy. In 1995, the American physicists Eric Cornell and Carl Cornell succeeded for the first time in cooling atoms to their lowest energy level, just 1/1,000,000th of a degree Kelvin above absolute zero, which earned them the Nobel Prize in Physics in 1995. The temperature achieved in the laboratory by Cornell and Weyman was much lower than the minimum detected in outer space. The B-Einstein condensate obtained by Cornell and Weyman in the laboratory is a superfluid, a state of matter characterized by the total absence of viscosity, The theory exists that space-time is a superfluid. Space-time is the mathematical model of the general theory of relativity that combines the three spatial dimensions with time into a single mathematical model of the general theory of relativity. Space-time is not only a frame of reference containing physical objects such as galaxies and celestial bodies, but a physical substance in itself, similar to an ocean of water. According to this hypothesis, just as water is composed of innumerable molecules and atoms, space-time contains microscopic particles on the same level as water, so space-time contains microscopic particles on the same level as the universe, contains microscopic particles at a deeper level of reality than even the most modern instruments can grasp. The theory proposes that space-time is a superfluid of zero viscosity. A strange property of these fluids is that they do not rotate massively as a liquid does when it is. It is speculated that they could be the starting point for the formation of galaxies. Number 5. Big Bang Theory. More than 90 years after it was proposed by Belgian priest and scientist George Lempt, the Big Bang Theory of the origin of the universe remains the most universally accepted theory in the scientific community. George Lempt, the Big Bang Theory of the origin of the universe remains the most universally accepted by the scientific community, supported by two key observations, the cosmic microwave background and the expansion. According to this theory, the universe began from an initial point that gave rise to matter, space, and time. Matter, space, and time. Big Bang or Big Bang was a derogatory name used by the English astrophysicist Fred Hoyle to mock the theory in a radio program on the BBC in London in 1949. 1949, according to the Standard Model, the Big Bang took place approximately 13.8 billion years ago. Although this pattern itself does not try to explain how the Big Bang occurred, but rather how the universe evolved from the Big Bang to between 300,000 and 400,000 years later, when stable and unstable atoms began to form in the universe. Stable atoms began to form, and the cosmos became more transparent. The Big Bang Theory is the predominant cosmological hypothesis for the oldest known epochs of the universe and its subsequent large-scale evolution. The Standard Model postulates that in the beginning, the universe was in a state of ultra-high density and temperature, then began to expand. After its initial expansion, the universe cooled sufficiently to allow the formation of the first subatomic particles, and later the atom's giant clouds of these major elements were later joined by gravitational attraction to form planets and stars. Gravitational attraction to form planets, stars, galaxies, and other cosmic entities. After the Big Bang, and this is no longer part of the Big Bang Theory, the universe began to undergo a progressive cooling and expansion, whose further development was based on processes observed in particle physics since the beginning of the universe. Observed in particle physics since Mater observed that a constantly expanding universe should go back in time to a single point of origin, Most scientists have relied on his idea of cosmic expansion. The idea of expansion had its major milestone in 1929. We hope you found this video useful. If you have anything to add, please share it with us in the comments section.